So let's look at an example of using our formula to calculate weight. So here's our example. So a steel drum with a mass of 56 kilograms is sitting on a wooden support frame. What is the weight of the steel drum and what is the normal force exerted by the wooden support frame? So what we actually have here is that our first step is to actually calculate what is the weight of the steel drum. So what are we given the question? We're given our mass. So our mass is 56 kilograms sitting on a wooden support frame. So remember that our formula is that weight is a force and it's equivalent to mass times acceleration, but acceleration in this case is going to be gravity. So it's just sitting there, so we have the force of gravity on it. So our weight is 56 kilograms, so we don't have to do any conversions there, it already is in kilograms. And the gravity is a constant, is 9.81, and that's meters per second squared, which is what we need it in. So when we plug that into our calculator, we get a weight of 549.36. And remember, this is a force, so the weight is given in newtons. So the weight is actually 549.36 newtons. So if we sort of think about what's happening here, we have a steel drum, and it's sitting on some kind of wooden support system. So remember, this has a mass of 56 kilograms, so gravity, force of gravity is pulling it down, and we have a weight of 549.36 newtons. But remember, we have this normal force that's happening on the wooden support frame as well. So we do have this wooden support frame is also pushing up with a normal force, right? The steel drum is not merging into the wooden support frame, so we do have that normal force happening there. So we have a force coming up towards it as well. So the force, normal force on the steel drum by the wooden support frame has to be a balance of the two. So in this case, when you're actually dealing with things that don't merge with each other, often we think about weight is equivalent to our normal force. So weight down by gravity is equivalent to the same force, normal force up, so that we don't have anything moving or merging or shifting together. So if you sort of think about it as a sort of a free body diagram, and often this is used when you're talking about different forces related to each other, we have sort of the center idea of it. We have a force going up in this case, and we have a force going down in this case. Our force going down is our weight being pulled down by gravity, and our force going up is the normal force of the support frame. So these are actually balancing each other out, why there's no movement happening between them and why they're not merging together. So in this case, your normal force is equivalent, 549.36 newtons. And again, it's because there is no movement, no shifting between them, so these have to be equivalent to each other.